Okay, so this is a quick video over what we did in class today, solving a absolute value equal to a linear. And we did look at the graph. Let me go ahead and pull those graphs up. There you go. So we can see from the graph that the line and the absolute value are intersecting at 4, -3. Let me just highlight that real quick. So that's right here. Okay. But since our directions are to solve for x, we really only care about the 4. So the answer to this equation should be x equals 4. But we need to make sure we can do that by hand. So let's try that. So here's our equation. First thing we need to do is simplify this right side. So distribute out that -2, which results in a -2x and a +12. Then we've got +12 and -7 to combine. That leaves us with our +5. Now we can add over the -5, which gives us a 10. Now we need to get rid of the 1/3. You can either divide the 1/3 or multiply by the reciprocal, which is 3. So if you think of it as multiplying by 3, we've now got -6x and a +30. Okay, so our absolute value is by itself, so we're ready to split. And this is the part that's no different than any other absolute value. You're going to split one side equal to exactly the way it was, so -6x plus 30, and then one side equal to the negative of that. Just like we always do with absolute values, we split one positive, one negative, and then we solve each of them. So let me just pull this over. So here is my solving for that guy. First thing I did was subtract my 1x over to the -6, which caused the -7. Then I subtracted my 30 from the 2, which caused the -28. Then divided by -7, which caused the +4. Okay, so that's one answer. And then on this side, first thing we need to do is distribute through this negative, which causes a +6x and a -30. Again, subtract your x over from the 6x, which leaves us with only 5x's. Add the 30 to the 2, now we have 32, and then divide, and so we've got x equals 6.4. Now, we have gotten two answers algebraically. We've gotten that x equals 4, and we've gotten that x is equal to 6.4. But, I'm going to flip back to our graph. In our graph, whoops, lost it. Not that. Let's try again. There it is. In our graph, we got that just x equaled 4, not that something else was happening somewhere else, just one answer. So if you remember in class, we talked about when we get two answers like this, we have to check them. So that's what this slide is for, two checkings. So in each of these, all I did was plug in. On this one, -4, I plugged in for x, and I plugged in for x, so that was going in for x here and here. And then I worked that out. And then also I plugged in 6.4 for the x in the absolute value and the x in the linear. So what you can see is when we plug in -4, we get something that works. That's good. That was what was supposed to happen. Remember, x equals 4 was supposed to be our answer. Here, when we plug in 6.4, we don't get things that are equal. So remember in class, we called that an extraneous solution. So really, our only answer is x equals 4. Okay, so you do have to make sure you check all of these. Just solving is not going to be good enough. One thing we did talk about in class is that, remember, you could get two answers if the line is crossing twice. You could get one answer like we just did where the line is crossing once, or you could potentially get no answers if the line is completely above or completely below the absolute value. So keep that in mind. You do have to check your answers to see if you have maybe one extraneous solution, so you'll only have one left, or maybe both are extraneous and you'll have no solutions left. Okay, so if you want to stop the video now, you can. I'm going to keep going and do one more example. So here we go. So this is the one that I had up on the board right at the end of class where we were talking about how this is a different graph than we're used to because of that 4 in with the x. But for solving purposes, it's the same. So first thing we're going to do is distribute out this linear, distribute that 2 through, which results in the 4x plus 2. Now our goal is to get the absolute value by itself. So we got to add the 6 over, causes the 8. Divide by the 2, causes the 2x and the 4. Now it's by itself, so we're ready to split. We're going to say that the inside is equal to the positive of this, and then the inside is equal to the negative of the right side. So there you go. Inside is equal to the regular positive, and then the inside is equal to the negative of the right side. And then we solve each of those. So here's my solving for the one on the left. I combine my x's by subtracting 2x over, then I subtracted 5 over, then I divided by 2, so negative a half. On this guy, distribute that negative through, add the 2x over, which causes 6, subtract the 5, which causes negative 9, divide by 6, which causes 1.5. And again, especially now since we don't have a graph to look at, we don't know if both of those answers work, if one works, if neither work, so we have to check. So, checking each of these, negative 0.5 and positive 1.5. And there we go. So again, just plugging in for x on both sides. That's what this is. I just kind of separated it so I wouldn't get confused. Same thing over here, just plugging in negative 1.5 for x. So if we look at our results, they both work, right? So here we've got that negative 0.5 works, it leads to something true, and so does negative 1.5. So this must have been this first case where the line ends up crossing the absolute value twice because both answers worked. Okay, so this was our last one. Hopefully that helps. Make sure you stop in if you have any questions.